So what I've done here, guys, is I combined the malware and benign, right? As you can see here, they're like 56. 28 plus 28 is 56 minus the title column is it's like 56, right? Correct. And so I also designed the dataset. I dropped this file name and then this MD5 as we had that instruction earlier, and just leave this one. This will be our classification column, right? As you can see from here, now it's just this, and these are the malware part, and down is like the benign file. So guys, this is for task 2-1, right? And this is the one that I already dropped the file name and the MD5 hash. And so I make this like, the classification column, right? And over here it says to do this, use cross validation to compare 4 different features selection strategies. Choose the value of K, number of features selection. So over here I select 17 features, right? And also 10 for the percentile, like 10% of the features selected, right? So it's being fed over here. I'm select K best. And so I'm going to run this. There's a little bit of library error there, but those are just library. My line of code up to 66 only, and it's complaining about line 113 or something like that. But it indeed give us result over here, right? And it looks like the random forest have a good accuracy over here, right? Compared to this four methods. I played around with different kind of selection over here. Like I selected about 200, and percentile is 70%, and also the k-fold over here, how many times we will divide the features, right? Right here, split, right, for the k-fold, and it gives like result. But these are the things that we can change, and then we pick which one we like. And so yeah, this is lab 5 task 2, right? Dash 2, this one, up to 3. So it's gonna help fill up this table here, right? So pretty much what it's asking here is to create a Python script, calculate cross-validation using stratified K to split tenfold. So basically, there you go. We have to define the cross-validation strategies, and we will have to put tenfolds over here as indicated here. And I will also include K-fold and stratified fold just to have idea in the output which one is our choice, right? Okay, guys. As you notice over here, I increased the number of features selected and also the percentage over here to be fed on select K best, right? And you can see the select K best dramatically outnumber the rest of it. So we understand this: the more features we selected, it's the select K best is going to perform more accuracy compared to the rest of them, right? As we saw earlier, random forest seems to be the top one, but now select K best seems to be having more accuracy. What also needed here is to create a pipeline with 2-step feature selection and so on. So this is the part where it does that, right? And remember, we can change the kernel to poly whatever option we have there, and we will have to calculate cross validation for F1 scores, right, for mean and the standard deviation. So these are my output here. I ran it already, and we will have to fill up this table, like I said. And so yeah, I fill up this table over here because I printed the K fold. We can get confused, so I just put select K best stratified fold over here as SF. But pretty much these are the information that I gathered from this part of the code. Output over here, right? I just print the K fold for our reference purposes, but I just need the stratified fold to fill up that table. So I did extra for that too. Bonus. Ding, ding, ding. So like I said, I'm not going to use ASMA's dataset. I will have to use my own dataset. And so for the one I scanned before that I used Kappa, these are the sort for the malware, right? There are 28 I separated from, I mean, not yet, but I separated the 28 malware. And so I also scanned with the entire file that I downloaded from the malware science, this with the Kappa also. And this is the one that the result of that. Now I'm saying here that I will have to reduce this all the scan with this one. I will minus this one, and then it will output this file here, reduce 28 malware, right? So pretty much I will do the same thing with the benign. So I don't need to show you that video because the same steps. So with those two programs that I ran, I should produce these two files then, and then this bash script will actually combine those two, right? Result, and then this will be the result, right? Reduce 28 benign and 28 malware. I reduced the whole data set. So that's the idea of this output here. It's not yet done because I have to balance this data set, and that will be my final data set. And as you can see here, when I combine them, you can see the joining over here. But the thing is, this one is 940, and it's not yet balanced. So I have to balance this data set. And once I balance it, I will create a pickle file from it. So there's more process to do. So as you can see, this is the balance data set right now, right? Uh, it end up at this row column 1879 because we need 939 malware. This is given 939 benign as we saw it earlier, right? So we just have to add up more malware like to even up the data set. So as you can see, this is the middle cutoff of the data set, right? Is over here benign is 939 because we have one title there. So pretty much it's 100% balanced right now. FYI also, this data set, the source is like we removed the 28 files, right? 28 because Kappa just read 28 out of 30. So I removed those 28 files, right? Actually, I removed the other two too because it can't be read anyway, so it didn't add it to the data set. So I removed that originally from my previous videos. And so this will be our model, right? To create our model, we have to drop the file name and the MD5 hash. So what is left of is our target, which is I put malware equals 1 benign 0, which is pretty much the same. So this is balanced data set 939 malware and 939 benign. So this has 10879 rows, right? So if I going to scroll down, as you can see, 1879 and it says 1 over here. That means we know those are malware, classified as malware. So this is where I produce my pickle files, guys, right? And we're in task 4 and it says it's a little lengthy, and it is because preparation of the data is crucial. And so I'm just going to show you along the way how this is being done with the live classification and performance evaluation, right? And then I selected 100 features, and this is my target column title, right? And I split the data into training and testing sets, and I use decision tree classifier instead of select kbest, try to, and K15. I'm having trouble using that feature selection, so I tried couple actually, and this one is giving me good results. So guys, here this is my Python program to create a pickle file. So I actually load the CSV file, which I drop the file name and the MD5 hash, right? So I use decision tree classifier, right? I played around a couple of classifier. So that one, I put a note there, but not supposed to be there, right? And what this program produce will be two pickle file, right? The feature used for training, right? And also train classifier pickle file, right? Pretty much that's the way I can describe it. And so in my detector file, I loaded those two pickle file, like I mentioned, right? And imported necessary stuff like the time for the timestamp, JSON format, and so on. And it's gonna enumerate this path over here, right, for the extraction, so that we can have live classification as we indicated, right? Yeah, so it's gonna enumerate or monitor the extracted OPT zeek extracted directory, and then it's gonna calculate the MD5 hash and create a stamp, right? And then Kappa is also will run, right? And it's gonna check if the features are present in the file, and then it will create the vector predict file, right? If it's benignware, it's going to say benignware for classification, or if it doesn't know, then it's going to say ND, right? And also it's going to clear the path for the extracted file, so we won't see anything there, but it will going to create this file over here, detector log, right? Which is if I go there right now and check if there's a detector log, there's nothing in there right now. So let me run the program, and as you notice, there's no activity going on in the processor, so I'm going to run it, guys. Okay, I need a sudo because it's going to enumerate the permission. There's need a sudo permission, so it's gonna wait for us. I'm gonna go to the thing now, to the Metasploit, right? And download two files for we know this one is actually malware, right? So I'm gonna do it, and then this one, we don't want to run it, save it, and then we're going to select two benign. We'll see how it's going to classify it. So we're going to see it if it's going to actually classify it. As you can see, guys, start classifying the first one over there on the left, and you can see the processor start kicking up there too, right? Where am I right now here? Okay, we just go with this cdf-config one to save it. So 4 files, right? Make it even. Let's wait a little bit. One is being classified right now. Let's see if the file is already there. We can monitor its progress. ls. Yeah, it's there. So we're gonna cut it right now and read it. Okay, so the first two were malware. Is it right? This is right classification, and they're still running. As you can see, the program. Okay, there are 3 right now. So this is live classification technique, right? Okay, all right, it's actually done. So 4 of them is still waiting, right? But it's done, guys. So let me just stop this program. All right, and it's classified those two that we downloaded into this thing, right? All right. Okay, guys, so we're almost done. We're at the last part of lab 5, and we're at task 4 dash 3, A to C, and that's how I name my Python program. Pretty straightforward, so that you and me don't get lost where we are. So yeah, basically in this program, my program will read the detector.log file and extract the true values of the samples and perform the task, right? Classification report and confusion matrix and the ROC curve. So we only did 4 over there, like 2 benign and 2 malware, and it does a pretty good F1 score. So yeah, let me run this program and let's see the plot. There we go. False positive is on this side, true positive rate, and false positive, and you see this one over there, right? So precisely it did the graph for us. So thank you for your time watching my video. I hope you like it, enjoy, and have a nice day.